diagram, this image, this picture. So actually this one is at mechanical engineering. At mechanical, they have 3 labs with the overhead crane. Mainly designed with the building itself. Okay, so the idea is, this is the trolley that we mentioned. The trolley, this one can travel along this line, and also this part can travel along this line. So if you refer to the videos, so this any things that we bring at this payload, we can travel along this way and can move along this way. So that we can move the object, the heavy object, from one place to the other place using the crane. So we have this one. If you are here, we can go to the lab at mechanical engineering, so we can get the real picture, what is the process is. Okay, so the model of the system. Okay, so this is the model of the system. In general, we can represent the trolley along this way. Okay, so actually this trolley is represent this one. Okay, so the trolley is this one. The trolley. So we can move the trolley. We can move the trolley along the X line here. Along the X line from one position to the other position. At the same time, actually, you have the track here. So the trolley will goes to the another y direction. So maybe we can put the y direction, we can do y direction. But the problem given here is only for the x direction. And another one problem is the payload swing with certain angle. They will swing during the movement, the trolley movement. So there is the problem that we need to solve when we try to increase the speed of this trolley to move to get the fast response to the certain position. You will have the very high swing here, theta. Okay, so we get fast response but large swing angle. But if you try to reduce the movement of M2, the system becomes slow and you can reduce the swing. It's not too much oscillation of the payload. So these two parameters contradict each other, x and theta. And the x and theta is opposite, contradict each other. So if you increase the speed, you can fast achieve the set point x, but increase the theta, the swing, the oscillation of M1. But if you slow down the system, the response to the set point, the set position will be slow, takes long time, but theta will reduce, less oscillation. So your project is to make sure that you can achieve the set position with the minimized theta. So how to minimize the swing, the oscillation angle theta here? By controlling the force. To control the force, meaning that we control the top to the trolley. So the top here related to the electromechanical system. This is involve motor. So in our class, we model the motor, and the output of the motor is torque, opposite torque. So this way, you give the input voltage, and you control the EA supply to the motor, so meaning that you control the torque output to the mechanical system. So in this case, we are going to model to get the EA, and finally to achieve the set point X by minimize the delta. So how to get the fast response with minimum swing? Okay? Can you follow me?
Yes, madam.
Yes, madam.
So hopefully you can follow me. Otherwise, I don't know. Okay,
Already.
so you just respond the chat or whatever.
Okay.
Okay, so this is the objective of the project, to understand the basic knowledge of gantry crate. So the first part, task one that given in the student pack, actually just to understand the basic knowledge of gantry crate. And then task two, if you refer to the student pack, to model the trolley displacement. So trolley displacement with the angle payload swing at theta, actually a non-linear system. But we are given some calculation in the student pack to linearize the system. So we make some assumption from the non-linear system to be a linear system, and finally we can do some analysis, simulate the system using MATLAB, and plot the response of the system. Whether the system fast response or reduce the theta or whatever condition system, so we can simulate using MATLAB. Okay, so this is the task that we are given. So in this case, if you refer to the assessment, from the assessment, you have 10% assessment, if you refer to the CI, for the maybe quiz, tutorial, and assignment that contribute to the CLO1 and CLO2 is 10%. Okay, so for our class, we are doing project-based learning. The assessment for this 10% CLO1, CLO2, we will get from these two parts. So this one will contribute 10%. And then we have another 10% for the CLO3. If you refer to that one, CLO3, that we have three quizzes. And this one is will be the same process as another groups. So we have online quiz for all sections. So this one is compulsory. So that was the 10% is CLO3 for the whole group of students. Section 1 until section 15. So we have almost 400 something students all registered for SAEE 3133. Okay, so for the CLO4, that's one contribute 10%. So all the model simulation, how do we get the response, how do we evaluate the performance, so we can assess for the CLO4. And then for this CLO4, so we have 5% for the MATLAB demo. You can remember that last time I told you that 5% is individual demo. So every student must have MATLAB installed in your laptop. Okay, so we assess individual MATLAB for every student. So the mark is 5%. And another 5% is come from your final reports of the project. So final reports, what is the content of the final report? I will give the rubrics. We have the final report to assess your MATLAB, not to assess your modeling, because modeling already assessed here. We give you the marks here. So the first part, task 1 and task 2, actually this one is for before your break. The part 1 of your semester, week 1 until week 7. So the second part here is MATLAB is week 8 until week 14. So meaning that before the break, we should have the 10%. After the break, we do start modeling. So use MATLAB and so on. We have demo for every student, should be demo, and I will ask the items in your block, your Simulink. So hopefully everybody knows, and not only one represent the whole group. So everybody must know how to represent the model on the Simulink. So maybe your model is same model, but you know how they develop the model. So this is the individual demo. Okay, so to assess the individual MATLAB ability, 5%. Okay, so this is the assessment. So 10%, another 10% CAO3 is the short quiz. We have 3 short quiz for every sections, and then another CLO4, 10% from the MATLAB. Okay, so for your first task, actually we start from last Monday, when I assigned you the task, the question from task 1. Question from task 1, this is the 1 question, 2 question. If you refer to the table, this one 3, this one 4. So every one of you have this question. So please do some research, just Google and so on, get information about the country crane, what is the purpose, what is the control problem, so, and then maybe what is the input, what is the output that we have discussed, displacement and the theta, what is the output, the supply, so what is the sensor that we should use if we want to be a closed loop system, the position, the angle, so search about sensors there. And then the control system category and the control objective of the crane system. And just give some ideas. So after you everybody doing the self individual thinking. So week 2. So week 3, I have given you a group X and Y, correct? Problem 1 and 2, they have group X and group Y. So they are groups in e-learning, X and Y, for the specific question. So please make sure you exchange the idea within your group. You can access what you get, student 1, student 2, student 3. So finally, what is the final uh, outcome from the problem 1 and problem 2 from group X and should have from group Y. Okay, so every group maybe the same output as, or maybe different. It's okay, but just discuss within your group and get some conclusion, and your discussion and conclusion should be report in the e-learning that link that is given. Okay, so after week 3, so we have this one we call that expert group. You expert in problem 1 and 2. You expert in problem 3 and 4. So finally, we are grouping you again that we call the home group. So every group here, home group, consists of person that in charge problem 1, 2, 3, 4, 5, and 6, 7. So I have maybe group A from any of you that expert in problem 1, 2, problem 3, 4, 5, and 6, 7. So your home group consists of all the problems here. So will be given after week 3. So now you discuss among your problem based on your problem first.
So, Doctor, the home group is not assigned yet.
Not signed yet.
Yes.
So maybe from somebody from X, from group Y, is from your section. Because the e-learning is separate section 3 and 4. So I just put the section 3, your groups, and section 4, another groups.
Okay.
Okay, so you have this one. So we just simply do, now you just think about whatever your case, your problems, and then join with the group discussion, whether you group X or group Y, and then we assign you your home group. And during the home group, so you have a complete answer for question 1 until question 7. After that, you can exchange the information with your groups, and finally you want to write a minute of meeting here. You want to write this one maybe letter, maybe week 7 or week 8. So I will give the link for peer review within your groups. So we give you letter. Okay, so this is a simple minute of meeting and also the peer review. So the rubrics also will be given. I will put at the e-learning, so you know what is the things that you want to report. Okay, test 2, modeling of gantry crane system. So this one, a few basic model has been given in your student pack. So finally you need to get these two final output lah. The trolley displacement XT over the input voltage, and then the payload angle theta t with respect to the input. So we know that XT and theta t respond respond to the voltage. So when you increase the voltage, meaning that you increase the speed of motor, you can achieve the XT at the short time. But theta t will increase. So the main idea is theta T must be minimum as you can. So how to control the voltage? So I will set the range of the voltage for every group. So maybe you can get randomly. So this one after week 5, week 4 or week 5 we will give you. So at the end of week 7, week 8, you need to submit the report. So report here is consists of your task 1 and task 2. So all the modeling, simulation, and modeling, and finally get the transfer function of the system in time frequency domain and also in state space model. So this is the first part. And then you have the simulation work and analysis. This one, after break, we have the hands-on a little bit. I think the student knows about the MATLAB, maybe not the control toolbox. Okay, so we introduce the control toolbox, how to design your system using the Simulink before we start your task 3 until 5. Okay, so at the end we have a demo session. This is individual and also the group report. So make sure that you understand to the MATLAB. So you get the marks for the individual. So report is group report. Okay, so maybe a few reflection will be given, a short question, maybe just 1-2 question to make sure that you follow the case study. So before the activity, maybe week 3, self-study. So everybody think about the individual problems. After the group activity, week 8, after the progress report, maybe so you know the whole system operation. So you will get some knowledge about the country code. And
Doctor,
then after,
can you please share this slide through e-learning so we can keep?
I will give to e-learning. I will give to e-learning. Maybe I will add some more information. This one is maybe very limited. That's why I just write something here. So I will put it better,
Yes.
better writing.
Okay, thank you.
Okay, reflection, and then we give you reflection, and then this one is your final, what we assess you. We assess you. Actually, it has been discussed what is the CLO1, CLO2, based on your activity before the break. So you have done the basic knowledge, basic principle of the gantry crane, do the modeling, write the minute of meeting and the progress, you get 10%. Okay? And then the second part is the modeling, simulation and the MATLAB development. There is another 10%. Week 9 to week 14. So this one is individual and this one is group. Okay, so all the rubrics will be given so you know what are the things that we assess the students. Okay, not a very complex report lah. Just a simple report that can give 5 marks to the student. Okay, so any question for this one, this project? Okay, so I think I will remind you.
Doctor.
Yeah?
Doctor.
Yep. Okay.
I have question.
Yeah.
For the first one, you have divide per group, right?
Yeah.
And then macam saya task nombor 5 group X. So saya kena buat task nombor 1 dengan 2 ke? Macam mana?
Your task actually not
Saya
number 5. I think your task, where the task here? Sorry. This is the task given to you, correct? This actually this is the problem. Task 1,
Yes.
problem 5, correct? Okay. So the first you think about the problem 5 first. Think yourself. And then you join the group X or you group Y. Discuss about the problem 5. Okay? And then
Okay.
week 4,
Thank you.
we form you a complete group from problem 1 until 7. So in your group, you have the person expert in problem 1, 2, 3, 4, 5, and 6, 7. Meaning that complete system in your group. Okay? Can you follow? Can you imagine? But the process, we go after week 2, week 3, week 4, I think we can understand that. Because we do it online in class, basically it's much easier to do, right? To do with the class. Okay, but now you just think individually, and then if you think that you have done the individual thinking, you go to the group. Group with 3XY already in your e-learning. Give your idea, give your information that you get, so share with your friends with the same problem. Okay, so finally you can get the conclusion of your problem.
This one only an idea, right?
Yeah, the idea.
No need to do MATLAB.
No.
Okay,
Just
thank
the
you.
idea. The basic concept that you learn in chapter 1 actually. In chapter 1. Okay, so you just relate with the real problem in industry. Okay, any more? Any question? If you don't have any question, okay, so you can start lah. Okay? You can start with the activity. I will just remind you every week. So not during the class, maybe outside the class. So through your Telegram group. Maybe we create the Padlet, so many platform also not very good. Okay. So it depends. Padlet also can. So we can create one link for your project. Okay, if you don't have any questions, so we can go to chapter 2. Okay. Okay, so we go to chapter 2. Where's chapter 2? Okay, so chapter 2, okay, so if you refer to the syllabus, so chapter 2 is modeling of system in frequency domain. So we model the system in two techniques, in frequency domain and in time domain. So meaning that we try to get the equation of the system, the relationship of the output with the input parameters of the system using frequency domain and using time domain. So chapter 2 and chapter 3 cover the modeling process. Okay, so based on this chapter 2 for the modeling in frequency domain, and when we model the frequency domain, we will get the transfer function of the system. Transfer function. So hopefully you know the transfer function. you have done in signal and system. Signal and system, you use Laplace transform. We still use the Laplace transform in this class to get the transfer function of system in frequency domain. So finally, you can get the equation in TS, frequency domain. This frequency domain. So maybe your output will be CT become CS. Your output RT become RS. This is the transfer function. So we use Laplace transform. So make sure you can revise again the Laplace transform, how to convert the function from time domain to frequency domain. Okay, so we have electrical system. Electrical system here involve the three components RLC. So combination of the RLC, we try to get the transfer function. What is the output voltage to the input supply maybe. Okay, so we can see it later. And then modeling in mechanical system. So we have the translational system. Translational meaning then the XY direction. Translational system. Rotational system is the rotation in angle. Relation with the angle, we rotate the system. So we try to get the model and rotational system with gear. So when we try to increase the torque of the system to get the force, we must use gear. Something that gear, bicycle gear, gear, car gear, and so on. Okay, so this is the function of gear to increase the torque, of the system. And then finally, we combine the electrical and mechanical system, and you get the electromechanical system that involve motor, that involve circuit, and involve the mechanical, the gears, the rotational system. Okay, so we electrical student must have the electromechanical system. So we must cover until the electromechanical system. So we do the modeling in frequency domain, and after that, chapter 3, we do the state space equation in time domain. The same system, the same system will be in state equation in time domain. Okay, so if we can refer to the basic knowledge, when we talk about mathematical modeling, so meaning that we try to get the identical of the system, the relationship of the force, velocity, the displacement, the change of current to time, so how to get change of charge with time, to get current. So all the dynamical physical system that involve your Kirchhoff voltage law, current law, Newton law, so all the laws, physical law will be involved in the modeling. So try to remember again your physics knowledge, so will be used in modeling process. So Ohm's law, momentum, conservation of energy, so we must know all these things. Okay, so when we do the modeling, as we discussed just now, we can do in frequency domain and time domain. When we do in frequency domain, can be continuous and discrete. Continuous time and discrete time. So in our class, we only focus on continuous. We get GS, transfer function, in S domain. For the time domain, we focus on the continuous process, modeling, and finally we get the state equation. So finally we get something like this. You have the state variable, you have the input variable, output variable, and derivative of the state variable. This one is derivative of the state variable. This is your state variable. What is the state variable? We will go to chapter 3 lah. After this. Okay, so this is our syllabus covers. Frequency domain, time domain, but only on continuous time domain. Okay, so we just revise again. Revise the Laplace transform to how to get the transfer function. So hopefully you still can remember what is the Laplace transform. Laplace transform in for your signal and system. You have this using the Laplace transform. If your input is, I just put the variable here, maybe you can put ft or rt. If you can Laplace, you can get in S domain. So S here is your frequency. Frequency is your j omega. J omega. That is frequency lah. So for Laplace transform, any function, you Laplace the function ft, you can get fs. So how to get the fs here is your ft with this component. You integrate. Integration of ft with exponential minus st dt, you can get the fs. Fs. Alright. So if you can remember, if you inverse the Laplace, this is inverse. Inverse the Laplace transform of fs to get back your ft. Alright, so we can do the Laplace transform to get fs or inverse to get the ft. Okay, so if you can remember that if your function is ut equal to 1, so meaning that your fs become, you must integrate 0 to infinity. Your ft now is 1, multiply with exponential minus st dt. Alright, so you need to integrate this one. You can get exponential minus st divided by minus s, correct? You integrate this one. So you can get 0, infinity. So what happened to your system? Finally, you can get exponential s with the time is infinity divided by minus s minus exponential minus 0, your time is 0, divided by minus s. Okay, so you can refer what is the exponential infinity. S times infinity, you can get infinity. Divided by minus s. This one you have minus, minus. And exponential 0. Exponential 0 divided by minus s. Alright, so you can, finally you can get 1 over, this one becomes 0, this one become 1 over minus s, minus minus become 1 over s. So revise again how to get how you integrate this one. 0 to infinity, 1 multiply with exponential minus st. Just follow this formula. Any function that you have. This one function is 1, you can put 1. This your function is x, you can put x. If any values, any function. If your function is sine omega t, you can put sine omega t here. You can get the fs. Okay, so finally, if you refer to the slide or your module, you have the module, or you can get this table from any books. this Laplace transform table, I just simplified this one, something that we use in this course. So if your function is actually 1 here, 1 multiply with ut. Ut is actually unit function. So basically ut here actually equal to 1 for the t greater than 0 and 0 for the t less than 0. This is the definition. The function is 1 and unity. So if you put this one is 1, your function is 1 ut. What we have done from the previous example is 1 here. Ft is 1, meaning then this is your ft. 1 equal to 1 over s. If you Laplace, you can get 1 over s. Something that we get here, you get here 1 over s. You can test, so the result will be 1 over s. But if your function here is 10, you can put 10 here. And the function will be 10 over s. Okay? So this is just a simple example, because most of the process during the modeling, we use this table. So some we are not trying to integrate the function to get the Laplace transform. We just use the table to get the Laplace transform. And also we have the theorem, linearity theorem. If you put the k here is the constant, they become kfs, something like that we have done in Ft equal to 10. We change the k value. So the linearity theorem. So maybe you have two functions, Laplace f1 plus f2. It can be split into f1, f1s. You can get f2s. Now this is linearity theorem. So most of the time we use this theorem. Okay. So maybe this one differential equation is very important. When we Laplace the differential equation, something like we relate the current equal to dq over dt. So current is dq charge over t. Charge travel in t time. So you can get the Laplace transform. Or maybe you need to calculate the speed, d distance over dt. They involve the differential equation. So we need to get the Laplace transform. So this one is very important. The first order of differential equation and the second order of differential equation. So most of our system, we only involve until second order differential equation. So this one is very important because that involve force, involve acceleration, involve current flow. So that's why we still use this one. And then you also must understand the final value theorem. When we have a system, so what happens when t goes to infinity? So this is your system with function t. When t goes to infinity, meaning that at steady state condition, the first chapter we have the steady state response. Steady state response is the response of system when t goes to infinity, meaning that at steady state. So all the function at t goes to infinity, so we can use the Laplace transform by using this one, the theorem. Limit s goes to 0, s fs. Fs come from the ft, you Laplace become fs, and you can put s at the beginning and substitute s to 0. So you can get what is the final value of the system when t at infinity. When t at infinity, so we know the accuracy of the system. What is the final value of the system at t infinity? So we can compare with at t set point. At the set value. Okay, so finally we can identify the accuracy of the system, or we can calculate the steady state error. Okay? We call that steady state error. Okay, so error of the system at t infinity. What is the difference between the system and the set point? The value of the final output system with the set point. So final value theorem is very important in our course. So we always use this one. Differential theorem, and also this one, linearity theorem. But I think we are not using the time shift. This one actually is time delay, not involved in our syllabus. Some process they have time delay, so we need to put time shift theorem. But this is the things that important that in our class. So these two tables during test or exam will be given. Don't worry. These two tables, Laplace transform table and also the Laplace transform theorem will be given during the test and final exam. Okay, so any question until now? No question? No.
No.
Okay, no. So you can follow,
Yes.
So this is just the recall again. FT become FS, reverse back, you get FT. So given the FS, you get FT. You just revise this slide. Okay. So if you don't have any problem, you need 5-minute break, or you want to continue.
5-minute break.
5 minute break.
Okay.
5 minutes.
You can
5 minute
wait 5
break.
minutes. We come back at 5 minutes. You can left and join again, or you can stay here. Or you want to ask something, you can ask now.
So we're not dealing with numbers, basically in equations, right?
We're not dealing with number. When we have a system,
I mean, we're gonna generate equations, right?
we generate equation, but when we have the real circuit with the value of R, L, T, or maybe you have the mechanical system with the value of mass, friction, the spring. So the equation become numbers, right? But in S domain, you still have S because we use Laplace transform. Okay, so depends on the system. If the system in variable, you can get variable transfer function. If the system in values number, you can get the values. Okay, so when we try to plot the system response, so we need the value. We cannot plot based on the variable. So you will have the values after that. Just the intro is more on variable, but actually there is the values, the numbers that relate the input and output. Okay. Any more questions?
Okay.
mentioned many times, transfer function. So now we should know the transfer function. So if you refer to this diagram, this is the transfer function. If I put this one, I put this is your GS. I just put variable now, but after that we have the GS, the values. So GS is the transfer function. Transfer function is the Laplace transform of output signal, CT, your output over your input. When we Laplace CT, you can get CS. When we Laplace CT, you can get CS. In general, when we Laplace, we put in capital letter. We Laplace RT, you can get RS. Okay, so the GS is the transfer function of your system. So meaning that if you have a few systems in your system, you have maybe you have the first system, meaning that G1S. Go to the second subsystem, you have another transfer function, G2, maybe your controller, your amplifier, and then your motor, you have your G3S, and then you have maybe your plant, and finally your output and your feedback. Also, you have the transfer function. In general, feedback with the symbol is HS. You can put G also can, but this is just the symbol variable. In generally we use. So you have the input RS and your output is CS. So all the components have the transfer functions with the S domain, in S domain. So all this block you can combine and finally you can get what is the CS over MS. That is the transfer function of the system. So the equation that relate the output to the input. So the equation is in frequency domain or in S domain. We call it transfer function. If the equation in time domain, we call that state space equation. That is chapter 3. So now your equation in S domain. S meaning that you get the transfer function. Okay. So this is just the information. So if you have the input, differential equation, so something that involves force, velocity, and also many components involved in your system. So you have A N, B, differential order, NCP over DT, and so on. This is your output. This is your output. This is to represent your output. Over equal to B, dr over dt, differential equation dr over dt, and this is your input. So if we Laplace all the differential equation, this is just the information, but finally we will do this one. Just information, don't be too difficult to understand this one. Okay, so finally you can get, if you Laplace dct over dn, you can get this one, s over n cs. How to get this? We use the Laplace transform theorem. The differential equation of n order, so we can get this. We can get this one. Laplace ct, you can get cs. Laplace dn over dt over m, you can get s over m rs. Laplace rt, you can get rs. So finally, if we rearrange this one, we bring the rs and we group all the information about the rs, and the left side, grouping with the cs. So you can get the cs over rs if the equation if you have numbers, they become number. So this is the transfer function. So actually the transfer function is come from the differential equation of physical model. So the output equal with the input, conservation of energy, momentum. So the output equal with the input. So this is the theory. So after this we design and we derive the equation. So now this is just an example, right? Because our system is involve the differential equation. When if you can remember that if you have velocity equal to distance over time. So if you have the dv over dt, actually you can get acceleration. Alright, acceleration. You can get A. Or you differentiate ds over dt, you can get v, velocity. That is very important. F equal to ma. So we apply when we do modeling in mechanical system. So actually, this slide actually want to represent you from the differential equation of motion, differential equation of your electrical circuit, so we can get the information what is the output over the input of the system. So what is the output? We can group all the information, differential equation. Finally, you can relate the output with the input. The force output with the displacement. You can get F equal to ma. And so remember that F equal to ma, a simple one. But here it become dv over dt or become ds over dt squared. So you must remember this one. Otherwise, you cannot model the system. So also define the torque of the system for rotational, and you have I equal to dq over dt, traveling of charge with the certain time t, you can get current. So all the information will be used during the modeling. So the main idea to get relationship between the output to the input of the system based on the differential equation of the physical system. Okay, so we go to electrical system first. Because you are familiar with electrical, you have the circuit and system, circuit analysis, signal and system, so all about circuit. But now I'm not teaching you about the law, Kirchhoff law, mesh analysis, nodal analysis, whatever analysis that you have, and we just use in this class the simple as possible. We use maybe a Kirchhoff voltage law, whatever is easier, but we can use any method to solve the problem, but not a specific. We are not ask you use the mesh analysis. Not. If you're familiar with mesh analysis, you can use mesh analysis. If you're familiar with nodal analysis, you can use nodal analysis. You Thevenin, whatever you're familiar with, you can use to solve the problem to get the transfer function of the system. Not a specific method. We just use whatever you know, you understand from the previous subject. Okay, so maybe you understand the Ohm's law, V equal to IR. Just revise again. You are electrical student, you must know this. Kirchhoff voltage law, total voltage equal to the source, V1, something like this. So V1 equal to V2 plus V3 plus V4. This is the source, this is your component, plus V6. Or you must understand the current, Kirchhoff current law, total current flow in equal to total current flow out. Kirchhoff current law. So you must know all the basic knowledge here. So maybe in our class we only use these three components. These three components only. No amplifier, what your transistor. We are not model that components. We only use combination of capacitor, resistor, and inductor. So what is the combination? The circuit series and parallel. It depends on the question lah. So the idea is just these three components. So I know that all students familiar with these components. So you know what is the capacitor. Capacitor. We put the symbol here, you know that it's capacitor. If we use this one, you know this resistor. We are not ask you this capacitor or resistor, the values and whatever. So only these three components, and you must know the relationship between current and voltage. Current, what is it? Voltage and current and voltage. Voltage charge maybe, if possible, you need the voltage charge, you know. Current equal to dq over dt, so you must know the relationship. And impedance, everybody knows the impedance, or admittance. 1 over impedance is admittance. Okay. So for these three components, we derive the equation to get the relationship and convert into S domain. So we take the example one by one. We take the example. If you can take this one, V equal to, or because our Laplace transform theorem, we have this differential equation. In general, we use based on this. Actually, if you know one relationship, you can create another two here. So you must know one, and then you can create the second, because this one just to rearrange, and you can get the integration here. Because dv over dt, you just bring all to the left side. So finally you can get Vt 1 over C integrate to It dt. So we derive this one first. It equal to dc dv over dt. So if you have okay, so we start with IT. Okay, you have I T equal to C dV over dt. So V is function of T. Okay. So this is the formula. You know that any components of involve the capacitor. So current flow here, I. So what is the voltage across this one? Okay, so from this one, if you Laplace, so we Laplace this equation, Laplace the whole equation. So you Laplace I T equal to you Laplace C dV over dt. Right? When you Laplace IT, you refer to the theorem, you can get I S. So you refer back to here. You Laplace IT, you can get IS. You Laplace FT, you can get FS. Alright, so this any function of t, you can get function of s. Okay, so if you Laplace IT, you can get IS equal to C is a constant. If you have value 10 farad and so on, you can put the value. Must use the standard unit lah. Farad, Henry, Ohm. Don't use microfarad and so on. So use the standard unit. So you have C here, constant value. And then you Laplace the dV over dt. So if you use the theorem, you can get here S V S. Laplace dV over dt, you can get SVF by, we assume that the initial condition equal to 0. So you use the first order of differential equation, this one. So this is the first order of differential equation. We use this one. So we assume that initial condition is 0. This one becomes 0. So finally, you can get SFS. If your function is V, they become VS. If your function is I, become IS. So this one function is FT, they become FS. So any function. The thing is you refer to the table, try to get the first order of differential equation. Okay, so from this you can get the relationship. If your input is I, or your input is V, it depends on your system. So if I put here IS over VS, what is the final? You can get CS. So remember that your impedance, VS over IS actually is 1 over CS. So this is your ZC, correct? ZC. Remember? ZL is LS. ZC is 1 over CS. Okay? So how to derive this one? Actually come from the basic formula of differential equation of the components. So finally, your impedance actually is 1 over CS. Or your admittance equal CS. Your admittance. Or conductance, you call it conductance. So GS and CS.
Doktor nak tanya.
Yeah.
CS tu S besar ke S kecil? Macam
Okay.
S tu stand untuk apa? Untuk sebelah C tu.
S this one, wait, sorry, this one goes on. CS, small letter, but C times S.
Dia dah selepas Laplace lah kan?
Yeah, after you Laplace.
Okay, thank you.
Can you remember that you have J omega
T
T?
kan? Okay, thank you, Doctor. Thank you.
Okay, so this one
Saya terlupa. I forgot it.
The same thing. You just use whatever you know from the previous subject.
So, Doctor, when we do this, we neglect the initial condition. It's not there, right?
Yeah, we assume that the initial condition is 0.
Oh, yes. Okay.
Otherwise, your equation becomes CS plus the initial value.
Yes.
So that's why finally, if you go through all this, maybe the simple one, resistance is very simple. If you Laplace Vt, become Vs. R is constant value. Laplace It become Is. Straightforward. You don't use any differential equation. And unless this one, Vs become Rsqs, correct? When we differentiate dq over dt into S domain, become SQS. So for inductor also, you can use the same process. Vt, you can get Vs equal to L is a constant value. If you have value Henry, you can put Henry. Di over dt become SIS. That's why when you use the L inductor, Z impedance is V over I, they become LS or J omega L, correct? J omega L. So J omega is the S. J omega is S. S is J omega. Don't confuse, the same thing. But now we use in S domain, we put J omega equal to S. So remember that in this case, S here is your J omega. So representing J omega lah from the circuit. So if you can remember one relationship, I think this okay. Otherwise, this one just use this formula to get the current and voltage relationship. You just bring all the information to the left side and put the IT. How to get IT? You integrate VT over DT. So easier if you can remember this integration part, you can put integration part. If you can remember the current voltage relationship, you can use this one. But finally, you know how to Laplace the equation. That is the idea. The rest to get impedance, admittance, I think everybody knows that one. Everybody know how to get the impedance and admittance. Okay, so the unit is still the same. V voltage, A amplifier, Q charge, coulomb, farad, ohm, and H Henry. So hopefully that you can refresh again your knowledge from the previous lecture, from your previous syllabus topics on your course. Okay, so maybe you can just this one. I think this is summarized from the table. So how to get, if you have component R, relationship with the IT, VT, how to get IS, VS, just to show in S domain. S VT, you Laplace become VS. This one also, this is VT, V equal to IR, everybody know V equal to IR. But now you put in time dependent. V, not only V, but V of T. V inside your bracket T. V varies with time. I also varies with time. So when you Laplace, V become VS, IT become IS. So now all the signal will varies with time. So inductor, you can use the same information, or you want to use the in charge equation. So the I dt, I is dq dt, you can get this one. But I think if you can remember one, the rest you can do. So the idea how to get LL, so this one you have used all this information. So you just refresh again, so remind what you have done.
Doctor, what is QS?
Q charge.
Oh, charge, yes.
Charge. dq over dt
Now
is
I remember.
current.
Yes.
Everybody knows,
Yes.
but just to refresh again. We're not going to do modeling. Now, after this, we do modeling. We are not return back to this one. You must know how to get the Laplace equation for the components. Okay, so This is the simple circuit. I think everybody knows how to derive the equation for this circuit. Voltage input equal to voltage. If you put here voltage of inductor, voltage of resistor, voltage of current, capacitor, so finally you can get V input is your VT equal to VLT actually plus VRT plus VCT. Everybody knows Kirchhoff voltage law. But now your voltage with time dependent. So your voltage V is VT, not just put V. So now the question is to get the transfer function of your output. Now we assign the output is VC. This is your output. And this is your input. So the idea is to get your output over input. This is transfer function. How to derive the equation? Your output now is VCT over VT input. So your output is here. This is output VC. Okay. So you can do a very basic what we call voltage divider. Differential equation method or mesh method, nodal analysis. But the thing is how to get VC here. I think everybody know the voltage divider, meaning that total impedance of C divide by total impedance for the whole ZL plus ZR plus ZC multiply with V input, you can get VC, correct? What is the voltage VC here? Equal to the impedance of VC divided by the total impedance of the circuit multiply with input. You can get VC. This is a very simple voltage divider concept. Can you remember? Yeah.
Yes.
So this example actually we can follow, but finally it's up to you to make a decision. Whether you want to use a simple method or you want to use equation, something that given here also can. But we can see we can try both approach. So maybe we try the difficult one first before we try the simple process. Okay, so if you try this one, find the transfer function relating the capacitor VC with the input VC. Actually, very simple question, right? Single loop. So you can get any VR, you can get VL, you can get VC, but the question is you want VC over V. But actually, if you have voltage here, you have value L, value R, value C, you can calculate current, correct? Current flow. You multiply ZL with current, you can get VL. Multiply R with current, you can get VR. Multiply impedance of this one, ZC with I, you can get VC. Very simple circuit, but sometimes when we design this one, it can be difficult. Okay, so we refer to this equation. So hope everybody know how to derive the differential equation of circuit. Okay, so if we derive the differential equation, if you remember that L di over dt, you can get this one is actually your VL. L di over dt is VL. R times IT, actually this one is VR. And 1 over C IT dt is this one is your VC. You can refer to the table. You can refer to this table. This one. For capacitor, this is the formula. For inductor, to get the V, this is the formula, or this one, the formula. Okay? You can refer to this table lah if you confuse this one. But the idea is VL plus VR plus VC is V input. Okay, so what is VL? LDI over dt. What is VR? RIT. Current darab dengan resistor. What is VC? 1 over C integral IT dt. So, equal to V. Okay, so because this one we have integration, we have differentiation here, so we need a uniform equation, and finally we put in the same format. So how to change this one? Maybe you can change to charge. So charge is dq over dt. And when you integrate IT here, you can get the dq over dt, you integrate become qt. IT here, just put the qt, dq over dt. di over dt meaning that you di over dt here, you can get the power of the qt over dt square. Okay, so in this case, your equation become the same variable. Qt dq over dt, d order to qt over dt square. Okay, so you know that qt is c vc. You can refer to the table. Okay, so if we can substitute dq over dt here square, so we can get the vc over dt. For the q over dt, you can get the vc over dt. And for the qt, you can get CVC, but cancel with VC, you can only have VC here, equal to VT. Just substitute VT inside this equation. So finally, you have the equation that have only your input and your output. This is the output that we need. We cannot use this equation because this is not your output. The output we need is VC. So your equation must contain VC and the input Vs. Until you can rearrange this one, group all this and bring the VC outside, you can get this equation. So meaning that you have the Vs equal to all this thing multiply with VC. So finally you can get VC equal to Vs. Sorry, VCS. You can get 1 over something here because we bring this to the left side. 1 over, and then they rearrange, you can get this one. You can try and get this output. 1 over LC S square as one. You just rearrange. But actually, you put in proper order, and you can get this order is start from S2, and then S1, and then this one actually S0. When we form the transfer function, we arrange the order of S. You can get something like this. This one. So if we put in block diagram, so the transfer function here, this one, actually is inside your block. Your output is VC, your input is V, and the equation here is your transfer function. If you have the value R, L, and C, so you have the values here, and the values that you can put in your MATLAB program, and you can simulate to get the response. plot the graph. This is we call that transfer function. Okay, so we just complete this one. So this is the simple one. So hopefully we are not going to stress to solve the complex problem. Maybe this is a single loop, three component RLC, but looks like very complex, and we derive the differential equation. But now you just Laplace the components. This is the second method. Second method. So now, first Laplace the component. So Laplace component L. The impedance become Ls. Correct? J omega L. So hopefully everybody remember this one. Laplace R, we don't have any differential equation, so R become R. So you Laplace the C. You can get the impedance of C. Impedance of C is 1 over Cs. So we Laplace the component at circuit level. Laplace L, R maintain R, you Laplace C become 1 over Cs. Okay, so if you can revise again, your VC actually 1 over Cs times Is. So meaning that your I here also you Laplace become Is. Your input VT, if you Laplace, become Vs. VCT become VCS. C here represent the component C. Actually, the subscript here is C here. Okay, so finally, you know that VR is IR. VL is J omega Li or LSIS in S domain. So finally, actually the same process, this is your VR plus VL plus VC equal to V. The same process as we have done using the differential equation. Okay, so if you have this one, you have this, so finally you can rearrange it. I bring this one. I bring Is outside. So meaning that you have R plus Ls plus over Cs equal to V. Input. So VL plus VR plus VL plus VC equal to V. So you substitute what is VL, what is VR, what is VC. Substitute this value. And group this one. But the question is find VC over V. But now your parameters involved here is Is. So you must get the relationship. How to get Vs? How to get Vs here? You can use this equation. You can use this equation. From this equation, Is actually equal to If. So C S VC S. So Is here is C S VC S. So remember, this S with this S different. S here, S multiply with S. SC multiply with S. VCS, S here in bracket belong to VC. Okay, so don't confuse. So VC here actually is VC, and then you multiply with R, Ls 1 over Cs equal to Vs. So you know now VC and you have Vs. And finally you can get VCS over Vs equal to, you bring this one to the right, what happened? 1 over CS R plus LS plus 1 over CS. So if you try to rearrange this one, you can get this equation again. If you try to prove that you get the same answer with this. Try to prove that using the simple method, using the voltage divider method, to get the VC with the previous example, you should get the same answer.
So, doctor, are there any situations that we cannot use the simple method and we have to use the hard one because the simple one looks way easier and faster?
Yeah, it depends on you.
So we can use whichever method we want in any problem.
No problem, no specific method. You can use also the loop, a mesh, you create the current, a loop, and so on also can. But I just teach a few method maybe you can use from your previous knowledge. So maybe this one is the simple one lah, just Laplace the component at circuit level and derive the Kirchhoff voltage law. This is just
Yes.
Kirchhoff voltage law, very simple one. And just substitute again because your equation in IS, that your question in VCS, you use this formula to relate the I with the VC. And finally, you can get in terms of VC, now VC over VS. Okay, so this is the idea. So maybe we can try next class, or you can try your own first. You have two loop system. Maybe you can try this one after this. This is a very simple one. Using potential divider also can. Very simple. Don't need to use loop and so on. As simple as possible. But some students using Thevenin also can. But the solution may be half of paper, but they try to solve until 2 pages. And so also can, but at the end you get the same result. But depends on you. We are not specific for what method we should use. And use the simplest as you can. Okay, so this is the idea lah. So make sure you try to understand this one because we bring this one until chapter 3. So many students very confused how to relate the current, voltage and so on. When you relate to the circuits analysis, everybody will be confusing. A lot of confusion. But mechanical system is more easier to understand maybe. So, but circuit analysis, because there are many methods you can use to solve the problem. That's why confused. For mechanical system, very straightforward. No other methods to solve the problem. Because that's why one student cannot do better in the modeling of electrical components. But actually it's not too difficult because the thing is you have done in many subjects. Okay, so any question after we continue the next class?
Hello.
Yeah? Okay.
Madam, can we go to slide 18?
Slide 18.
18, yeah, the last slide.
18, okay.
Yeah, wait. Is this one? Can we go down a bit? How do we get S prime?
S prime?
Yeah, I mean, whatever.
This one?
Yeah, this one.
No, the S prime.
Oh, thank you. No,
Okay.
I was confused.
Yeah. Not S prime, S order 1 actually. I want to show this is order of S. You can see this is order 2, we arrange the order of S for the transfer function. This is actually order 1.
Okay.
This one don't have S. Actually, S order 0.
Yeah.
This one S order 0. I put this one S order 0.
Okay.
So this one order 1.
Okay. Then thank you.
Okay. Any more? Okay, so if you don't have any question, we stop now. So you can do some revision before we go further for any other loops. Okay, thank you very much.
Doctor, will you be uploading the videos on the group chat?
What?
Will you be uploading
Thank you, Doctor.